All right, in this lecture, I want to talk about a DAX filter function called filter. Now, filter by definition returns a table that represents a subset of another table as defined by some sort of filter expression. So, a very simple syntax here. First argument is the table that you'd like to filter. This could be a lookup or a data table, doesn't really matter, just needs to be a table. The second piece, or the second argument of the filter expression, it's a Boolean true-false filter expression that is going to be evaluated for every single row of the reference table. Now, a couple of very important things to call out here. Number one, filter can accommodate more complex filter expressions than the standard calculate filter parameters can. One great example is that you can actually integrate measures into your filter expressions within the filter function. Like the last example that we have here, where we're saying product price is greater than the overall average price. And the other important thing to note here is that filter is what's called an iterator function, meaning that it scans or iterates row by row by row by row through an entire table, testing that filter expression, that true-false statement. And for every row where that expression returns true, that row is kept, it's preserved. Any row where the filter expression is false, that row gets cut out. So as a result, filter scans row by row, and it chops out or cuts out any of the rows that don't meet the filter expression criteria. And then by the time it's gone through that whole table, you end up with a subset, a smaller table of that original table containing fewer rows, and only the rows that meet the filter expression are those ones that are preserved. So again, this is different from how calculate works. Calculate isn't an iterator function, meaning it doesn't actually scan row by row and eliminate rows from the table. It just identifies the filter context and modifies it. Filter, on the other hand, is an iterator. It's actually producing a new table as a subset of the original table based on whatever filter expression you're using. So, important point here, filter is used to add new filter context, and it can handle more complex filter expressions than calculate by referencing measures, for example. And since filter spits out an entire table, it's commonly used as an input to other functions like calculate or sumx, just like we saw with the all function. So, little tip here, because filter is an iterator function, it can be slow and it can be processor intensive. Not a big deal at all if you're working with manageable file sizes, but again, as a best practice here, don't use filter if a standard calculate function will get the job done. All right, so let's open up our AdventureWorks file, and we're going to practice building a brand new measure using this filter function. All right, so we're back in our report, and remember that we had added this overall average price measure. Actually going to delete this other matrix real quick. All right, we had added this overall average price measure, and we had created this using calculate and all. And now using this column, I actually want to create some sort of measure that will calculate our total orders, but I want to calculate total orders only for products that are greater than the average retail price or this overall average price, right? So basically, hey, calculate orders that are greater than the $714.44. So let's create a new measure, and we're going to call this high ticket orders. And again, we're going to start by calculating our total orders. And this is where things get interesting. For the filter statement here, let's step back and think about this for a minute. So to recap what we're trying to do, we're trying to return a value that's going to capture the volume of orders, right, total orders, but only for high-priced products, or products with a retail price that are greater than this overall average price, which we know is $714. We might first be inclined to say something like, all right, so for the filter argument, let's bring in our product price, right? And we want to say where that is greater than our overall average price. And we'll lock that in. All right, and then we get this error here. And the message isn't super helpful. Again, kind of classic Microsoft fashion here, where some of these error messages are a little wordy, or if you don't know exactly the terminology or the nomenclature that they're using here. It can be really tough to discern. But basically what this is saying is that you can't use a measure reference here as part of the filter within Calculate. All right, so let's edit this. And if we delete our reference to our measure, we can actually hard code in the value, right? So where our product lookup price is greater than $714.44, we'll lock that in. We don't get an error here. Again, we'll format this, and then we'll add this into our matrix visual and take a look at what we get. All right, high ticket orders. All right, perfect. So you can see here, high ticket orders populated on the bike rows. That's the only product category that's generating sales for products that are priced over that $714, which again makes sense. So we can see that 11,312 were categorized as high ticket orders out of our total 25,000. Something here just isn't really sitting well with me. I don't like the fact that we had to hard code that number. It's not scalable. What happens if we make changes or updates to our product list or the data set? What happens if we refresh in the future? It's kind of sloppy here, and I'm not a big fan of it. So let's head back to our high ticket order measure. And so what we're going to do here is see how filter can accommodate this more complex filtering logic and also make it scalable. So what we want to do is kind of delete everything. And so we're still going to evaluate total orders, but the modified filter context that we want to use is actually create a new table using filter. So from here, the base table that we want to start filtering is going to be our product table, product lookup. In the filter expression, right, the second argument of filter here, this is our product price is greater than our overall average price. We'll close that parenthesis and then close it out for Calculate as well. So again, just to recap here, what we're doing is we're saying produce a table based on the product lookup table and keep the rows where product price is greater than my overall average price. Keep those rows where the price is greater than $714.44. And then once you have that table, then evaluate the total orders against this virtual table that was just calculated. All right, so we're going to hit enter here. And if we've done this correctly, our value here shouldn't change. All right, so this refreshed and gave us the right number. So that's great news. Now, obviously, this is just one example of how filter and calculate can be combined, but hopefully a good example of how these functions can work together.